Data handling. Data presentation. Grouping data. Bars with differences. Circle graphs. Grouping of data. Let us take an example to understand the term grouping of data. For example, consider the following marks out of 50 obtained in mathematics by 60 students of class 8. Now, the number of times that a particular entry occurs is known as frequency. Example, frequency of 22 is 4. If we make a frequency distribution table for each observation, then the table would be too long. So, for convenience, we make groups of observations, say 0 to 10, 10 to 20, and so on. Data presented in this manner is said to be grouped, and the distribution obtained is called grouped frequency distribution. It helps us to draw meaningful inferences like most of the students have scored between 20 and 40. 8 students have scored more than 40 marks out of 50, and so on. Each of the groups 0 to 10, 10 to 20, 20 to 30, etc. is called a class interval. Observe that 10 occur in both the classes, that is 0 to 10 as well as 10 to 20. But it is not possible that an observation, say 10, can belong simultaneously to two classes. To avoid this confusion, we consider the common observation will belong to the higher class, that is, 10 belongs to the class interval of 10 to 20 and not to 0 to 10. Similarly, 20 belongs to 20 to 30 and not to 10 to 20. In the class interval 10 to 20, 10 is called the lower class limit and 20 is called the upper class limit. The difference between the upper class limit and the lower class limit is called the width or size of the class interval. Bars with a difference. Let us again consider the group frequency distribution of the marks obtained by 60 students in mathematics test. This is displayed graphically as in the adjoining graph. Observe, here we have represented the groups of observations on the horizontal axis. The height of the bars show the frequency of the class interval. Also, there is no gap between the bars as there is no gap between the class intervals. The graphical representation of data in this manner is called a histogram. This sign indicates that we are not showing data for the particular group interval. Circle graph or pie graph. Have you ever come across data represented in circular form as shown? These are called circle graphs. A circle graph shows the relationship between a whole and its parts. Here, the whole circle is divided into sectors. The size of each sector is proportional to the activity or information it represents. For example, in this graph, the proportion of the sector for hours spent in sleeping is number of sleeping hours upon whole day, that is equal to 8 by 24, which gives 1 by 3. So, this sector is drawn as 1/3 of a circle. Similarly, the proportion of school hours is 6 by 24, which gives 1 by 4. Similar way, the size of other sectors can be found. If we add up the fractions for all the activities, do we get the total as 1? Yes, all sectors together become one full circle. That is all in this subtopic, students. We will discuss about chances and probability in our next topic.